So let's take the input given here in this example, and I will just place it here. Okay. Now let me put it in the form of array indices. So index of 0, this is house first. Similarly, house second and house third. Now we will use the bottom-up approach to solve this problem. So we'll start with the base case, starting with house 0, 1, and 2, and we will calculate that how for each of the cells that we calculate in DP, in our DP array, what is the minimum cost at that particular cell. So what I mean is, so here I have created like house as the rows. For example, 0th house is this house, then 1, and then 2. I am denoting it by the array indices. And these are the colors, the 3 colors which are provided. For example, the red one is represents the 14, 2, and 11. 2 is for blue, 11 is for green. Similarly, we have got these 3 costs which are given here for each of the arrays in the house that would be represented in the column. And this is where we will calculate. So here, for example, this cell, right? This cell means that for house 1, if I paint this house with blue color, what is the minimum cost associated? Similarly, for say this house, right? It means that if I paint the second house, that this array of index 2, this house, if I paint it with green color, what is the minimum cost involved in that? So this is how each of the cell represents here, which is our DP 2D array. Now let's start with the very first base case, because it's a bottom-up approach. And as we have seen in all the previous problems, when we solve this approach using this bottom-up approach, we start with the base case, and we see that whether we can reuse the problems that we have already solved in our previous subdomain problems, and if there is any algorithm we can derive from it or deduce from it. Okay, so let's start with the 0. So if I paint the first house with red color, right? Because this is our very first house, so we can see that there's only one choice, that the cost would be 14 here, because we are starting with the very first house. Similarly, if I paint the first house with blue color, the cost given here is 2, and similarly for green, it would be 11. Right? For the first house, is very simple and plain. We only give whatever the cost has been given for each of them. Now the things goes interesting when we go with first house, right? Here with the array of index 1. So as the problem statements say that, right, that if I paint this house 0 with red color of having cost 14, it means that I cannot paint this first house with the red color. I can only paint this house with blue or green. But here this cell represents this particular cell, which I am here right now. This cell represents that if I paint first house with red, what is the minimum cost? So what it means is that if I have painted this house as red, it means that the first house would have been painted with either blue or green, right? It couldn't have painted with red if I'm painting this house with red, first one. So that's why the formula would be that the minimum cost involved when I'm painting this first house with red, it would be 11 plus minimum of blue or green, right? Because we have painted the house first with either blue or green if I'm painting this first house with red. So it could be either blue or green, which I have painted the very first house, the 0th house with. And minimum of blue and green is 2, right? So it would be minimum of 2 and 11. 2 for blue and 2 and 11 for green. That's why it would be 13, right? Minimum is 2. So it means that up till this point, we have come to a conclusion that if I paint the house 0 with blue and paint the house 1 with red, because this cell is for calculating for red, then the cost associated with would be 11 for red plus 2 blue, which is 13. So this is the basic formula to understand here. It's very important. And here it's a bottom-up approach again, because we are actually choosing the values which was already calculated before here. So we are calculating this formula using. I mean, you're calculating this value by reusing whatever we have already calculated before. And here we are also deducing a simple algorithm here. So let's go with the other cell, which will make it more clear. So if I'm painting this first house with blue, right, it means that we have either painted the first house with red or green. It can't be blue here. We can't choose blue here. And the cost for painting the first house with blue is 14. So again, the same formula, 14 plus minimum of green or red, which is 11. And this gives me 25, right? So what does it mean is that if for this cell, if I paint the first house with blue, then the zeroth house would have been painted with green only. So green and then blue. And it at this point, it would be the minimum cost would be 25. Now let's go with the same formula again. Green is 5 for house 1, for house of index 1. And if I'm painting with green, I have to take the minimum. The first house would have been painted with blue or red only, not with green. And I can see that blue is 2, so the minimum cost would be 2. And for this cell, it would be 7. So it means that we painted the first house with blue and the second house with green. So this is the basic formula here, right? Right, guys. So, and I think it's a quite a very good example to understand dynamic programming, because here we are exactly following the paradigm or the pattern which is being used for the bottom-up approach. Now let's go with the last house second here. I mean, if we have got like multiple houses, we can just add here in the rows and the formula would be same. Okay. And now again, let's do the second house, the last house. If I'm painting this house with red, it means that the first house, this house with index 1, couldn't be painted with red, 11. It could be only 14 or 5. Right? So it would be 14 plus minimum of 25 and 7. For blue is 25, for green is 7. So it would be 7, right? So 7, which is 21. Now let's go with blue. Blue cost is 3. And 3 plus minimum of red and green, which is 7, is equal to 10, right? And green cost is given as 10 plus. If I'm painting with green, then we can only color this house with red or blue. Red cost is 13, so I will take 13, and it would be 23, right? Okay, now what we see is that here the minimum is this one, right? So this is our final answer. That is the minimum cost associated when we paint all the house. And in the last row, the last house, we calculated that this is our minimum cost out of these 3. So this is our final answer. So again, we can check that, okay, how would the final color look like? So we paint the house 2 with blue, right? So house 2 would be, I'll just mark it here as blue. And because this 7 is coming from here, this side, so it means that the house 1 would be in green. And again, this 2 is coming from this. So house 1 would be also. The first house, 0 house would be also. So this is the way we are going to color our 3 houses, 0, 1, and 2, blue, green, and blue, and having the cost of 10, right? Okay, so this was all about the dynamic programming approach. I think it's a very interesting problem to understand. In the next video, we'll solve the same in Java and submit it in lint code and see our results. So see you all in the next video.